Welcome to Chapter 6, Prior Knowledge. Okay, now we will start with irreversible reaction. This is just a revision. Okay, for example, A plus B produce C plus D. Okay, so what is irreversible reaction? Irreversible reaction is reactions in which the reactants convert to products and where the products cannot convert back to the reactants. Therefore, we only use one arrow to show it. Okay, so this is the forward reaction. So after A and B react, becomes C and D. And C and D cannot react to become A and B. Now let's look at what happened here. Okay, this is a irreversible reaction or one-way reaction. So the reactant will form products. Okay, now let us look at this. Okay, so initially, when time equals to 0, we have how many red atoms? How many mole of red atoms? 4. And then we have 2 white atoms. And then, is there any product form? Initially, no product form. So 0. So after 60 seconds, we have 2 moles of product form. And then finally, there will be no more reactant because this is a irreversible reaction. Okay, now how to represent the reaction in a graph? For example, I can write a concentration or I can just write number of mole versus time. Right, so for initially, I have 4 mole reactant and then at 60 seconds, it becomes 0. Completely react no more. Okay, another one is the white atom. Initially, it has 2 mole. Then at 60 seconds, it completely react and then reactant completely consumed also becomes 0. Now, our product initially 0. At 60 seconds, it becomes 2 mole. So at 60 seconds becomes 2 mole. So this is for irreversible reaction. Now, let's do one more. The purple one we have 6 initially, then we have 3 initially. Then after some times, okay, so initially no product form. Okay, you cannot see any product here. Then finally we have 0 reactant and 3 moles of product. Okay, change. What does it mean change? Change means how much has been reacted. Okay, for the purple atom, minus 6 because it has been reduced by 6 mole. And then for the yellow, reduced by 3. Okay, and then for the product, okay, the product is just forming, so it is formed by 3 mole. So finally, we have 0 mole of reactant because they completely react, and then 3 mole of product. So this is how we fill the table. Now, next one we go to reversible reaction. Reversible reaction means the products can be changed back into the original reactants. Then in reversible reaction, the reactants are products are never fully consumed. They are each constantly reacting and being produced, meaning that A plus B will produce C and D. At the same time, C and D will revert back to produce A and B. So this is a constant process. So that's why it is said reactants are products and products are never fully consumed. Now let us try another one. Just now we have tried irreversible reaction, one arrow. Now we are going to focus on reversible reaction, where we have reversible arrow. Okay, means that we have forward and backward arrow together. Now, initially, there is only reactant. So we have 3 mole of the 4 mole of the red and then 2 mole of the white. Okay, so initially there was no product formed yet. Okay, after that, okay, we can see that it changed to at equilibrium only 2 mole of red atom left, 1 mole of white atom left, and then we have 1 mole of product formed. Okay, remember this is reversible reaction. So meaning that at the same time the product is formed, and then at the same time it will change back to the reactant. Reactant is formed, then change back to reactant. Then again, okay, it is going on all the time. Because when it reaches equilibrium, forward and backward reaction is the same. Okay, now how to represent in a graph? Okay, I will show it here. Okay, let's say I use a concentration, okay, in a 1 liter, and then we have time. Okay, so initially we have 4. Then after that, initially we have 2. And then we also have finally 1. Okay, what does it mean? Okay. We don't know when is what is the number. Okay, the number of mole at equilibrium, okay, we have calculated is at 2. So meaning, okay, for example, at equilibrium it is, let's say we are 10 seconds, for example. So it will go down to 2. Okay, at this point, the concentration become constant because forward reaction and backward reaction is the same. And then for the white one, okay, this one is for the red one. Okay, another one is for the white one. It will reduce to, at equilibrium, it is 1. This is the white one. Okay, and then we look at the product. Initially, product is, there's no product form. And then at equilibrium, it becomes 1. So we will have 2 lines together. Okay, so this is the product. You can see here, the reactant will never reach 0 because this is a reversible reaction. The reactant change to product and then product change to reactant until equilibrium is reached. Okay, now I want to highlight this part. Now what happened is initially there is 4 red one and then changes is 2. Okay, now let's go back to the original one. Okay, now we look at this. Okay, originally it has 4 red one. Okay, so when it changed to product, it will consume 2 red one and consume 1 white one. Okay, and then product started to form. Okay, so this is what we call the ice table. Okay, now let us move on to another example. Now, initially we have, again, 6 purple atom, 3, and then we must know that initially there is no, okay, this is initial, this is at equilibrium, no product form. Okay, then at equilibrium we have 2 purple, 1 yellow, and then we have 2 more of product form. Okay, so what happened here is, what are the changes? 4 purple atom is used, and then 2 yellow atom is used, and then 1, 2 product is 4. Okay, so this is how we fill the ice table. Okay, another one. Okay, now we have 1, 2, 3, 4, 5, 6. We have 6 purple, then we have 3 yellow reactant, and we have 1 initially. Okay, initially we have 1 product. So let's look at what happens at equilibrium. Okay, at equilibrium we have 2 purple, 1 yellow, and 3 product. So what happens? What changes? So means that 4 purple atom is used. Okay, 4 purple atom is used, and then we have yellow, we left 1, so means 2 is being used. And then for the product, we have, how many do we have? We have 2. Okay, so 1 plus 2 equals to 3. So this is how we fill the ice table. Okay, we shall continue again, later with the calculation part. That's all for introduction for irreversible reaction and reversible reaction using diagram, using a picture to show first.